All right.
Everybody
see screen, not too glossy. Should I try to dim a light?
Can you say
Do you think this may help? Is that a little bit better?
There, that's good.
All right. Very good. Dora.
So everyone can hear me and everyone can see the screen, right?
Can you turn it up a little bit?
Turn it up some more.
I haven't bought my hearing aid yet.
It's up as it goes.
Okay, I can try to talk as loud as I can.
I can't get the TV sound to go through. Okay.
Okay.
Yep, we're good.
Okay, so first off, my name is Jeremiah Jeski. I'm a professional engineer licensed in the state of Minnesota, and I work for Houston Engineering. And I've worked with Margaret and the folks at the Middle Fork for probably 8-9 years now at Houston. And so just going to go over this presentation. This is identical if you were at the board presentation. But like Andy said, when we get to the end, we can kind of open it up for discussion. I want to go over the basis of the project and the results that we've got from it. So first of all, one thing when we start a project, we always talk about what the project goal is. And the goal that we had for this project is to do a big kind of overview of what's happened in the lake over the past, kind of a concise summary of that information, and then just providing the district and the Lake Association with some information that can assist folks in discussions about what to do about outlet reconfiguration or storage of water within the watershed to kind of help manage the lake level and the lake water quality within Elkhorn Lake itself. So the technical memo that I think went out with the presentation includes the following items. We provided a historical timeline for what's happened to the lake. And if I recall, that goes back to the early 1900s, so starting in 1938. We provided a review of the historic lake levels as they've been collected by various entities. We did some modeling and analysis for the lake itself and looked at some outlet modifications. We also did some analysis of pollutant loading and storage potential within the watershed, and that was a direct result of some of the work that the North Fork Crow watershed as a whole had done during their planning. We, like I say, identified some potential storage within the watershed of the lake and also some places for source reduction. And what that means is it's kind of a fancy word for when we talk about like cover crops and field management for agricultural areas. And then we also came up with some recommendations on how to proceed with the outlet modifications to the lake. Just wanted to go over the site overview, and I'm probably the least knowledgeable person in the room when it comes to the actual lake itself. But just to get everyone understanding what we're talking about, this is obviously the north east corner of the lake is where the outlet is. Here is the road that passes by. Here's the inlet. And everyone can see my cursor when I move it correctly, correct? Okay, good, because I'm going to use it to point a lot. Lake is down here. Here's the inlet. Here's where the road passes through. Here is what I'll refer to as the rearing pond or the pond throughout the presentation. Some important terms also, I will refer to this right here. That's labeled valved pond inlet structure. I'll commonly refer to it as the pond inlet structure. This structure out here, I will commonly refer to as the pond outlet structure. And then these two culverts right here, I will be consistently referring to as the roadway culvert, this one, and the driveway culvert. So, and then just all of this water eventually outlets into Alvig Slough to the northeast here. So starting with the timeline that we developed, like I say, it started back in 1963. And so the U of M maintains a really good set of historical photos. And so we started here pulling these different historical photos and looking at where the different structures were with regards to historical photos. So all of these structures were surveyed in by Houston, so we know where they are, and they were geo-referenced onto the historical photos. So as you can see in 1938, there was little or no development around the lake. I believe all these areas are probably some sort of agricultural field. There's no connection between over the channel at this point, except for maybe some sort of, just kind of truck path or something that maybe people used when it was dry. But basically you had a big wetland here, and the water moved out of the lake, passed through this wetland and right into Elvig Slough. And so for reference, like I say, you can see where those structures that we surveyed in here. Moving on to 1963, you can see that it's a little bit more farmed in this area. You can see that somebody has kind of built through this connection roadway passage here to get over to this area. Just looking at the maps, presumably, I think all of this land was owned by the same person, and whoever was farming down here was using this to get over and farm this area up by the highway. So then we keep moving into 1968. 1968 is when the DNR and the Spicer Conservation Club decided to kind of partner together with the county and build this rearing pond. And what I've done here is I've taken the original rearing pond design that was done by the NRCS, that's the National Resource and Conservation Service. It's part of the USDA. And I've overlaid it, sized it, and overlaid it on top of the property. And so you can see this original design, still had the roadway here. It was a little bit different alignment. We had the structure going underneath the roadway into the pond, and that was intended to be opened up to allow water into the rearing pond to fill it, to perform the rearing. We had an outlet structure so that water could leave. But a key thing here is that the original design had this spillway channel and a culvert from the lake here. So you can see this culvert leaving the lake, going underneath the road into the spillway channel that traveled on north and then dumped into Elvig Slough. And the purpose of the design of this was, one, to be the primary outlet for the lake along this channel when they modified it. So if you recall, before they put the road in, the lake would have just continued to travel on through here into the slough. And then the other purpose of this channel is when the water rises in this pond, it just spills over into this channel and drains out. It's a flood control method for this pond. And right away, if you're looking at the survey data that I have overlaid on here, you'll notice that the existing outlet that we have going out of the lake actually continues under the roadway here and then under this driveway. And so you can see the more or less present day aerial photo in the background. And, kind of one of the assumptions that, I make as an engineer when I see something like this is, this was the original design. And I'm guessing what happened was the NRCS engineers or the staff on site in 1968 that built this decided, we've got a high spot right here, and we've got a high spot right here, and we've got a little saddle right here. And if we can just run the water into this portion and cut down the saddle a little bit, it'll just gravity drain the rest of the way out to the slough. And so I'm guessing as a cost saving measure, what they did is they said, let's not put the culvert here, let's put the culvert here. Let's cut down this channel a little bit and allow the lake to outlet through here. And so that's what they did. They never built this overflow channel along the side. So now present day, or the earliest photo that I could get for this was 2019. You'll see that what happens here is there's the original culvert, and then there's the driveway culvert, and then it continues on through this property and eventually outlets into the slough over here. And the way that the pond operates is obviously you can let water in through this structure, and there's a weird structure that you can set the elevation of the pond, and then there's a culvert underneath this berm that was built that then continues into the slough. So one thing to kind of talk about here is, in the late 1980s, they stopped using the rearing pond for the rearing of fish. And what they did was, in that case, they shut it down. Or, if you talk to the DNR, you look at some of their records, they left it slightly open, and they kind of set this outlet height to about the same as the lake so that the pond and the lake kind of function together. But they allowed kind of the primary outlet of the lake to just be through this roadway culvert. Now, at the time, in the 1980s, the late 1980s, when they stopped using the pond, this property wasn't developed. And so what you had here was an actual channel that just ran through here. So ignore the driveway. And then what happened likely is when they developed this property and they came in and they built this driveway, they had to put a culvert in underneath the driveway because you can't block the flow from passing through here. And when they set that culvert elevation was about 3/4 of a foot higher than this culvert elevation. And what that effectively does is, if you want to think about this being the original outlet level of the lake, and then you come in and you put an outlet, the next outlet down 3/4 of a foot higher, that becomes what we call the new control elevation of the lake. And so now, rather than water having to get up to this height to get out of the lake, it now has to get up to this height to get out of the lake. And so that's what happened, more than likely, when they built this property. And so, moving on in this, I don't know exactly the year that that house was built or that property was developed, but I'm guessing it was in the mid 1990s to early 2000s based on some of the aerial photography that I've seen. And then in 2015 and 2016, and some of you in the room might even be a part of this, there were some lake residents that contacted the DNR about low water levels. And, I think what ended up happening here was this outlet was opened up, which is actually about 4 to 5 feet below kind of that natural water level of the lake, which allowed water to pass through the pond and pass into this outlet. And if there's no weir structure or no weir stop logs, these are logs that go into the weir to set the height. If there aren't any in this spot, then the water will just drain out of the lake and continue on like a bathtub. And over time, you'd see the lake drop. And so in 2016, the DNR went out and closed that pond inlet and announced that they're just going to operate it in the normal way that they had always decided, which was to slightly have it open, to set the weir logs and to just allow this to still be the primary outlet through the roadway and driveway culvert. Now, one other thing that we did was we kind of went in and we grabbed, there's a lot going on this graph, so I'll kind of explain it. On the y-axis over here, we've got the elevation of the lake, and this is just in a common datum that we use in feet. And then over on this axis here, starting from the top down, is the precipitation. So all this orange stuff represents rainfall in inches that fell over that time. And the blue dots are the actual lake level measurements, and then the lines between them are just the interpolation of that over time. So we've got the earliest we've got back in record is probably down here about 1977 and moving up into present day. Now, some of these lines that we have across the graph are, this red one is what's called the ordinary high water level. And so this is it's kind of a legal terminology that the DNR uses, and it really defines what the boundary of the lake is. The DNR has decided that at some point, if the lake rises to this level, this is the actual boundary of the lake. So when you talk about your shoreline or what is your property versus what is a public water, that's the elevation for Elkhorn, is this 1169 feet. And that's determined just based on looking at, the way the shoreline looks and how high the water raises, that sort of thing. This purple dotted line down here is the elevation of that original roadway culvert. So this point right here, this inlet of that roadway culvert. So when they originally designed the rearing pond, this is what they intended to be the outlet elevation of the lake. This green dotted line is the elevation of the driveway culvert. So this culvert out here, the inlet right here. And this is based on survey data that we collected. And so when they changed that, this became the effective outlet of the lake. And some of you may be seeing, where this plays an importance on this roll or on this graph. And you see that I just arbitrarily placed it on 1995. I said somewhere between the mid 90s to the early 2000s, this culvert was installed. But when you start to look at the lake level changes over time, obviously when lake levels jump, it's a result of rainfall. So you're getting some pretty large rain events in here that cause this to jump up. Another one right here that causes it to jump up actually above the ordinary high water level here. But what you'll kind of see is a drastic kind of overall average increase when that extra culvert goes in. So you're not seeing the water levels of the lake down here near the roadway culvert outlet. you're seeing them up here higher near that driveway culvert. And that's not surprising. That's what you would expect if you change the control elevation for the lake itself. So, you know, and then what you're going to see here, I've shaded. So this shaded area down here is the approximate range of that rearing pond. And so you can see that they were doing a fairly good job. I mean, there was some high rainfall events, but they're doing a fairly good job of maintaining kind of that outlet elevation. And then what you see up here is this shaded area is kind of that area of complaints. So that 2015, 2016 area where the lake owners provided some complaints. And you'll see there was a pretty big drop here below that driveway elevation, but then also almost down to that roadway elevation. And so this coincides with, you know, the only way that you drop below this green line is if you, number one, have a drought, or number two, this gets opened up and this is set very low and the water's allowed to drain out of the lake, pass through here and continue onto the slough. So that's the only way that you get these drops below the green lines, is those two conditions. So continuing on in the timeline, in 2017, the county, 2017, this is what the structure, this is the outlet structure coming out of the pond. So this structure right here. This is coming out of the pond in 2017. In January of 2020, Kandiyohi County actually contacted Houston Engineering and asked for a proposal to redo this outlet structure because of the shape that it was in. And the DNR explained to the county that they needed to replace the structure with the exact same structure that was in there. Ultimately, Houston didn't end up doing the work because the design was literally the exact same design. The county did it, I think, themselves. And in the summer of 2020, that structure was replaced. And that's what you're seeing down here on the right is the new structure. So pretty identical to the old one. And this is what I mean when I talk about stop logs being placed in the structure. So these are placed up here. That means once the water reaches that level, it flows over them. And there's a culvert underneath here within this pipe that goes underneath that berm and continues onto the slough. So then in 2020, September of 2020, Houston was hired by the Middle Fork Crow Watershed District to kind of do this assessment that we're talking about today. So two big takeaway issues that I want everyone to get from what we've talked about thus far is, number one, there was a modification to that lake outlet elevation in the late 1990s. Like I said, the roughly 3/4 of a foot, which pretty clearly shows that it's kind of resulted in these higher elevations in the lake. And then, so that's kind of the higher elevation piece of this. And then number two, there's kind of been a lack of management of this lake outlet in that this structure, which is the inlet to the lake, and we'll talk about that in a little bit, has been opened on multiple occasions without the proper elevation set on the downstream weir in the pond, so that residents have actually seen a drop in the lake level, considerable drop in the lake level over time, if that outlet is, or if that inlet to the pond is open. And so really we're kind of exacerbating the problem from two different ends. One, we rose the lake level of, or the elevation of the lake level with the installation of a driveway culvert. And then we've been dropping the lake level with the opening of the inlet to the pond. So what I want to kind of do is go over quickly. I don't want to go into detail of the modeling that we did. I'll talk a little bit about the different scenarios. There's actually, I think, 7 of them, and I don't want to get hung up on the details of all of them. But the big picture that people need to know is that we did kind of an existing condition model of the lake. So when I talk about model, we talk about rain falling on the landscape, running into the lake itself. We know kind of the volume of the lake. We know the outlets on the lake, and we model all of that, and we look at what does a rain event do to the levels on the lake. And then what we can do with that existing model is we can make changes to it that are potential engineering designs or structures that have been installed, and we can look at how those change what happens to the lake. So like I said, we did an existing condition model to start, just to know kind of the baseline. And then we started our first scenario. We started by just closing the inlet to the pond. We said, what if we closed off this and we only let this be the outlet to the pond? The second thing that we did was we said, all right, let's go ahead and abandon these culverts as the outlet. And let's open this inlet up all the way. And let's put some stop logs in here that are the same height as, this outlet of the lake. And let's operate it like this is the main outlet of the lake, the structures that are there. The third scenario, we did the same as the previous one, but we said, what happens if we make this connection bigger? So rather than being a 12-inch culvert, we put like a 4x4-foot box culvert underneath the road. Scenario number 4, we did the same as the previous one, but we said, all right, now let's go ahead and increase the size of this culvert outlet from the pond. The fifth scenario, again, building off that previous one, we said, let's make this weir a little bit bigger. And the way that we do that, I'll show a picture of this at the end, is lots of times you'll have what's called a drop structure within the lake. And perhaps you've seen these sometimes on the edge of lakes. They also use them in ponds a lot. It looks like a big manhole with a grate on the top. And the water, when it reaches that level, is allowed to flow up and over the grate into the manhole, and then it goes out through the pipe. Scenario number 6 would be the same as the previous one, but we added these culverts back. Really what we wanted to see as we were moving through these different scenarios is how much of a role does having 2 outlets on the lake play on the overall lake elevation. And then the last scenario that we did was we went ahead, we closed off this outlet here, and we put one of those drop structures actually on the lake running through the pond, and we set the weir elevation at a lower elevation than the lake. And if you want to think about it as operating the lake at a higher level and the pond at a lower level, and the water's able to flow through this drop structure underneath the road into the pond, and then the pond only gets to a certain height that is lower than the lake because those stop logs on the outlet are set to a lower elevation. They flow up and over those and out into the slough. So I just want to show quickly some of the results of that modeling. So these bars right here, you'll see the different scenarios are across the bottom. And these are all in the memo if people receive that as part of the meeting. This is the peak elevation. And so the highest elevation that the pond reaches, which is in blue, and the lake reaches, which is in blue, and the pond, which is in green. And we do this in engineering, we choose what we call design storm events. And so this is a 10-year storm event, 10-year 24-hour, which for this area is a pretty big storm event. It's about 4.5, I think, inches over 24 hours. And again, I've put these different key elevations on the graph. We've got the ordinary high water level of the lake. We've got the driveway culvert outlet elevation here. We've got the roadway culvert elevation here. And then another thing that we've put on here, that property to the northwest of the pond actually has a shed. And so this is the shed elevation, this dotted blue line. We wanted to see how the pond elevations rose in coordination with that shed, if the shed got flooded, basically. So one thing that you'll notice is a lot of the scenarios actually kind of result in the same. I mean, obviously the difference in the pond and the lake here is so great because this is the one in which we literally shut off the inlet to the pond. So no water is allowed to go into the pond. So all you're seeing here is the water that fills the pond based on the local runoff to the pond. I think a couple of takeaways that you see from this is, having that additional culvert outlet doesn't necessarily impact the bounce in the lake. You'll see that the lake, for a lot of these, the lake and the pond are at the exact same level, and they don't move relative to each other up and down all that much. So having both an outlet through that property, through the culverts, and having an outlet through the pond itself, having both of those outlets doesn't necessarily provide any benefit to the lake levels in terms of how high they rise when you get large storm events. Another thing, if you were to compare 1 and 2, if you compare the lake levels on 1 and 2, they're pretty much identical. That tells us that the pond isn't providing any sort of storage benefit to kind of buffer the bounce of the lake. The volume between the pond and the volume of the lake overall are so different that you're not getting any benefit to that. Another thing is that increasing the connectivity between the lake and the pond, so putting that larger culvert in between the pond and the lake, allows the pond and the lake to to do what we call tracking together. So they rise and fall at the same rate, which is not surprising. You've put a bigger pipe between the two of them. And so if you look at 1 as compared to 3, 4, and 5, 3, 4, and 5, you'll see that the peak elevations on the pond and the lake are pretty much identical, whereas they were a little bit different down here in the existing condition because there's a much smaller pipe out there right now. Another thing that we did for the district was we went in and we just kind of did a qualitative cost estimate. We gave some just kind of notes on what the different scenarios would cost. Obviously, not doing anything or just abandoning some culverts doesn't cost very much. Once you start getting into tearing up the road and doing new piping underneath or putting new structures in, you can get a lot higher based on that. Obviously, the most expensive one is you're going to go in on this scenario 5 and abandon the roadway culvert. You're going to put in a big box culvert. You're going to replace that outlet structure, which, in theory, that outlet structure was just replaced last summer. And so, in terms of common sense, you don't want to go changing that if you don't have to. I'm just going to take a little bit of time here to talk about some of this stuff. I don't want to get too much into it, but during the watershed planning, we had, for the actual watershed plan for the entire North Fork watershed plan, we had run kind of a program. Houston helped with this to identify potential storage areas within the watershed. That's what you're seeing on the left here, and potential management practices on the right. And so when I talk about storage areas, to see what we've got listed here is drainage water management. So this is when they put in some sort of structure to withhold water in wetlands, a pond itself, or what's called a WASCOB, and that stands for Water and Sediment Control Basin. They're typically things that you see on the edge of agricultural fields that allow sediment to settle out before the water runs off. There's a program that's developed by the state that goes in and actually identifies just on land where these could be. So we had this, so we kind of decided we would do this for the Elkhorn watershed. This black line is the entire Elkhorn watershed. The red area is what we kind of call the direct drainage, the stuff that we think gets to the lake right away. The blue area is kind of what takes its time getting to the lake because it has to pass through all these wetlands and that sort of thing, but eventually drains to the lake. What you're seeing on the right here is the management practices. So these are things like biomass, perennial crops, cover crops, reduced till and no-till. These are just areas that use NRCS criteria to identify where that can happen. The reason why we identified this is if there's a volume problem getting to the lake, this is information that the watershed district can go out and talk to landowners and try to hold some of that water back within the watershed. So to kind of reduce both in water and in pollutant load what gets to the lake itself. So just kind of a general discussion here about some of the recommendations that we've made. Those of you that drive across that road or go out there recognize this. This is what I've been referring to as the pond inlet structure. And if you were to look at the original NRCS, it looks very different than it was originally designed. It had a catwalk that went between those two posts. You could walk out there and you can see the valve on the top, which when you turned it, would pull open a vertical gate, which would allow water to pass through that 12-inch culvert or to cut off that 12-inch culvert. The catwalk is gone. You actually can't access it without going out on a boat. And the pipe itself has been propped up with some boards. I don't know if those are from the original catwalk or what, but from an engineering standpoint, that structure absolutely needs to be replaced. It's inaccessible. It's a hazard. I'm not thinking anybody's going in there in a water skiing or anything, but there is a potential for somebody to run into it or something if they're out on a boat. And it's also, extremely subject to if the ice is shifting and the freeze-thaw cycle being ripped out, crushed, destroyed, that sort of thing. And if it fails, and it fails in the open position, and what that means in engineering is that it fails and that gate is no longer covering the culvert, it'll just allow water to flow out of the lake into that pond. And if there's no stop log structure on the outlet of the pond, it'll just continue through like it did in 2015, 2016. Now, you're not going to just wake up one morning if that happens and the lake will be drained. It actually takes something like 3 or 4 months to drain the lake, provided no rainfall input. So it's just something that we modeled just kind of briefly to see what kind of that drawdown time is, we call it. So another thing that we talked about was kind of the outlet modifications. And so, like I said before, kind of those takeaway points where you've got high elevations, and the way that you can deal with high elevations in the lake is obviously put more storage in the immediate area around the lake to prevent water from running into the lake. And you can increase the outlet of the lake itself. So make it larger so that when that water does rise, it can get out of the lake faster and pass through wherever to get downstream to the slough. In terms of the low elevations, you can't do much about drought, but the one thing that you can deal with is outlet management. And that is having a set process for if that pond inlet structure and outlet structure are going to continue to be there, how are they maintained and how are they operated? And what do they become in the future? So, you know, and a third takeaway here is, like I said before, there's really no benefit to maintaining 2 separate outlets on this lake. There's the true historic outlet, which is underneath the road, through the pond and out the pond. And there's kind of this new outlet that was made as part of the breeding pond, which is through the property to the northeast. And then the last piece that I've got in here is connectivity of the pond and the lake itself. And so one thing that I mentioned to the board is that there's not a lot of benefit to putting a big huge structure in between the two that allows the water to fluctuate at the same rate. One reason is right now the lake itself, that inlet, is part of the public water, which is something that the DNR determines the actual water body, whereas the pond is not a public water. I believe the pond is actually on private property. And so you could run into a whole host of issues if you try to make that connectivity so great that the two fluctuate together. You might end up turning that pond into a public water, which subjects it possibly to things like shoreline ordinances and buffer laws and things that public waters have. Another thing I should mention before I go on too is, you know, the outlet from the lake through the private property, so underneath the roadway culvert and driveway culvert and then out into the slough, that's not designated as a public water either. And so there's no DNR control or no county control or anything on that actual water course. And so one thing to think about in that is, you know, if something were to happen with the driveway culvert and it were to fail, you have the lake would rise and you would have no obligation by property owner or the DNR or anybody to deal with that because it's on private property. So moving forward, I'll kind of talk about the ultimate recommendation that we had made to the district regarding what to do with the lake and the management. And the first and foremost one, like I said, is that pond inlet structure needs to be replaced. And a recommendation was to replace it with what we call a graded drop structure. And kind of the one that gets talked about in Minnesota all the time. And I don't want you to think that what would go there is something this large, but this is something that was put on Prior Lake. And so if you could imagine something like this built off the side of the road towards the lake, but it would be much, much smaller. In fact, we'd be talking about probably a diameter of about 4 feet, so no larger than your typical manhole. Something like this, where this elevation on the edge of this is set at the elevation of either the driveway culvert or the roadway culvert. And that would need to be a discussion between the Watershed District, the county, and predominantly the DNR, because they're in charge of setting lake levels and outflow levels on lakes. You'd set, like I say, you'd set that drop structure and then establish an operating elevation for the pond. And so this is very similar to that last scenario that I talked about. So I'll go back to here. So you'd be operating the lake. This would be pretty much, you can imagine the lake outlet structure being somewhere out here and the pond outlet structure being somewhat lower. And by that, I mean, going back to this, you'd be setting these stop logs in the pond lower than that outlet structure on the lake. And that, I think, would end up being a conversation between probably the property owner and And based on the placement of his shed and how high you want that pond to be able to bounce up before it can overflow into that structure and out. But by maintaining those two separate elevations between the lake and the pond, you're keeping that separation between a public water and a pond. Next, I would recommend abandoning that outlet through the roadway and driveway. One thing that's important to note, I'm going to go back to the photo here, is right now, this outlet structure, both of these structures are kind of under the jurisdiction of the county. And obviously this one has an easement because there's a road here, or a township road. So they have an easement to access and do stuff on this. There's also an easement in place to go in and access this. This is how the county was able to replace that. So right now, both of these structures have easements on them. This culvert has an easement, but there's technically no easement or no jurisdiction by the county. And this is where I talk about if something were to happen to this, it could ultimately affect the lake levels. And so changing the outlet of the lake, the general outlet of the lake, to this pathway already has the easements in place to deal with that. And then the last thing that we had recommended was operation and maintenance of things is key. If there's operation and maintenance of that existing pond inlet structure, probably wouldn't have had the issue where it was opened up and the lake was allowed to drop through the pond. And so whoever's going to maintain these structures, county, township, DNR, that sort of thing, there's going to need to be some sort of plan in place for this graded structure. If you put in a graded structure like this, it's undoubtedly going to get driftwood and weeds built up around it. Somebody's going to go out and clean those out so that this still functions. Same thing with the pond. Somebody has to maintain those stop logs on that outlet of the pond. This picture, by the way, is the replaced one that's there. When I was out there in November of 2020, they did not have any stop logs in it. And then this outlet from the lake was actually closed all the way. And so this is what was there. But eventually, somebody should put stop logs in there, determine an elevation, and actually lock them so they can't be removed or additional ones added. So kind of the where we left it with the board meeting was we just kind of discussed some next steps. And really the next piece is for folks at the district, folks at the Lake Association, to start having these conversations with the DNR, the county, and then the local landowners. And then also, as always, is to discuss funding options. I mean, there are grants that come down the line. You've got possible funding options through the Watershed district and through their watershed planning, that sort of thing. The county could be involved in that. But that's kind of the steps forward. And like I said, the next step here is obviously discussing this with you folks. This is kind of the landowners or the Lake Association folks on this type of work. But overall, that's kind of our recommendation on how to operate that. And really our recommendations are as in line as you can get with, I'll kind of back up here, really as in line as you can get with returning the lake outlet to kind of the natural outlet, quote unquote. I mean, we can't take out the road and we can't take out that berm, but we can, try to make sure that the water passes through that natural outlet, which luckily for everyone is under easement right now. So with that, I've spoken a lot, and I can certainly take questions about anything that we talked about. One thing that I would kind of ask is, I don't know how good the microphone is in the room there, but I don't know if people could either speak up or talk into it just to make sure that I can hear it. And I'll do my best to reiterate the questions when I answer them.
I can see this might get a little bit closer. Does anybody have any questions about the structure or anything?
Well, I know the outlet now going across Brian's driveway, the culvert, he had leak in there, so he filled it in, and I noticed the culverts are getting kinked in there.
What was that? Something about the...
You said the landowner with the culvert under his driveway possibly have had a leak in it, and something had
The culverts aren't laying straight.
Well, I can't hear it if you walk around.
Leak in there, so if that's gonna hold water back too eventually if we need to, or
if the culvert is raised, yes, it will raise it will raise the level of the lake for
the
a
one on the
raise.
south side is, the leak was on the north side of his driveway. So the stuff was running down the creek. But the other side, the one on the south side, that culvert is tipped up.
Okay,
You may not getting a true higher level of that, and ultimately, if we cut those out as one of the solutions,
Yeah.
I think you get a better flow plan,
Go through the new one, yeah.
and you avoid all the legal issues of having to deal with a private owner. Say, Brian's been fairly congenial on it, but he could cause problems, or say he sells the house and gets somebody else in there. You never know if it could be worse or better or what. So I like the idea. Again, this is for me to decide, but I like the idea of closing that other part off, that the culvert and the culvert lake control sections, and working with